Testing, testing, testing. Seems like we're good to go. Let me make sure the volume is working. Hello, hello, hello. All right, the volume is working. We're good to go. What's up? It's a thumbs up. Good. All right. Welcome back to part 2. I just had some breakfast and I'm ready to rumble. So if you just joined, basically what we did is we were trying to install Nerfstudio previously on the first part of this stream, and we were running into issues because of our CUDA version. So we went ahead and spent a bunch of time trying to debug that. It was kind of going nowhere. Ended up reinstalling CUDA on our computer and using CUDA 11.8, which it seems is the version you need. Because you guys will be excited to find out, but I reran the Docker command, and guess what? It fucking works. Look at that. Look at that. We're in the Docker container and it's working. So we are ready to rumble here now. We can actually use Nerfstudio. We can actually try to do stuff with it rather than just install it. Okay, so first thing to note here is we're going to basically try the Nerfacto, the data, and here we're going to point to this Nerfstudio poster. Look at that, it works perfectly. So if you are trying to install this on your computer and you're still dealing with the CUDA and tiny cuDNN, all that like assorted crap errors that we were dealing with earlier today, basically what you're going to have to do is you're going to have to upgrade your NVIDIA driver and your CUDA version to this 11.8 and probably something around 520. But once you do that, it should be good to go. And now we can actually see here, right, we are successfully training a NeRF with the example images that they have. And if we open up the NeRF viewer, you can see here we have the NeRF and its training. So each of these little squares or little triangles like this, right, they're like a little pyramid, is basically one image. And what you're seeing here is all the different images that are part of this poster NeRF data set. So you can see, I don't know, maybe there's 100 of them here, maybe something like that. And you can see how all of them are not just pictures, but they also have an associated position with them as well. So there's a very specific position associated with this specific picture. Okay. So we can, I guess, hide the images. We can, this square probably represents the volume of space inside which the NeRF will be created. We can hide the scene, I guess. Show scene, show images, refresh. Output render, fast, balanced, slow. Let's do fast. But this is going to be going on in the background. And during the meantime, we are going to be preparing our data set. So if you recall, we made a data set of our little cat mascot for this channel, right? Boo Boo the cat. Let's go into data and Boo Boo. No, actually Nerfstudio and then Boo Boo. And let's do NVIDIA, or not NVIDIA, Nautilus dot. Scratchy ear. Who was looking at me? Who, you want to come down here? Squint at your cat. Okay. So these are the images that we have for our cat, right? We have some back shots, we have some profile shots, and then we also have some forward-facing shots, and we have some three-quarter shots. So these were generated by Midjourney, so we're going to have to basically, and we don't have any camera positions for these. So we're going to have to actually create fake camera positions. So we're going to have to basically make a version of this file here, the transforms.json. And we're going to have to come up with a camera transformation for each of these images. So one way to do that is to do a bunch of camera math, but I think there's a secret way that we can do it here. So one thing that we can do is we can probably steal it from here, right? So let's just say that these images here, I guess these first 4 images, or whatever this is, 6 images, are front-facing shots. So we're going to say, let's say this is the front-facing shot here. So we can select one of these front-facing camera shots. And which one is this? Can we at least get the frame for this? Maybe not. How about we figure out what it is based on the actual frame name? Shit. Okay, so let's go here. Let's see. This is kind of the side of the chair. You know what's actually probably the faster way of doing this? It's probably this. So let's open up another terminal here. Go into our data, except this time we're going to go into the poster folder. Let's go into images. Let's do a Nautilus dot here. And let's see. So assuming that the chair is our cat, what is a kind of representative picture of this first angle here? Or actually even better, what is the representative angle for the poster? So something like what's the most forward headshot of the poster? Maybe this. So frame 0145, 0146, 0147. So basically anywhere from 142 to 146. So let's go back to here. Let's hide the images. You can see how the NeRF is getting a little bit better. Pretty good. So let's go into here. 145. It's going to be 0, 0, 0. 145, 144, 146. So actually, you know what? Why don't we make a new let's make a scratch page here. We need some scratch. All right. So front facing is 144 to 150. Okay. Then we also need a 3/4 kind of shot. So something kind of like this, 175, 172, 173, 174. The 3/4 shot is going to be 172, 174. So we're just trying to find images that have a similar pose relative to the center of the object to the cat images. Then we have the back, right? So the back is going to be a straightforward pick of the chair. So we're looking at something like 44 to 47. Back shot, 44 to 47. And we also need a profile shot. So profile shot is going to be not this profile, but more like this. So 0, 1 to 0, 3. Profile shot. 0, 1 to 0, 3. Okay. So now let's get number for each of these, right? So how many of these do we have? We have 3, 4, 5, 6. We're actually, you know what we need to do? We need to bring in our friend. Let's bring in a chat.openai.com. Can you give me a Linux terminal command that renames a bunch of PNG images into the following format? And we want frame underscore 000. Okay. Frame underscore 000. How many leading zeros are there? There's 3. 14.png. 00158.png. Okay. Sure, you can use the find command along with the rename command. So let's go ahead and open up a terminal here. Make that a little bit bigger so you guys can see it. Okay. We're going to copy. We're going to go into our data, to Nerfstudio, into our Baboo, into our images. Okay, we're here. They have these terrible names. So we're going to copy paste this command here, and we're going to type star iname png exector sprint 5 png 1. Okay. Is a rename command a real command? sudo apt install rename. Now let's run it. And let's see if we successfully rename some things here. 0, 1, 4, 5, 6, 7, 8, 9. Having some trouble here. PNG not renamed, frame 004 already exists. This is causing errors because some of the file names already exist. Okay, so now it's making a bash script for us. Okay, it's no longer using the rename tool, it's using the so it's touch rename.sh, vim rename.sh, nope, and put that in there. No, I want the whole thing. Copy code. Okay. Dot dash rename images. Or I guess we got a chmod plus x rename images. Then dot dash rename. All right. Well, there we go. Now we should have all of our shots. The indices aren't exactly what we want, so I don't know why we're getting that. But, you know, they're here. Okay, this isn't ideal because now they're mixed up. So let's rename this one to 1. Rename this one to 3. Name it to 4. And this one, let's rename it to 6. Rename this one to 3. We have 1, 2, 3, 4, all of the back shots. Then I guess we could do all the profile shots. Rename script is just so garbage. Let's rerun it again. And let's do vim rename.sh. We'll change it to like more zeros, and then like that. Let's do %08d. We're going to need to name them in such a way that they're all together. So let's do this. We're going to put an A for the profile shots. Good old manual data cleansing. Okay, so we have all the profile shots, then we have all the back shots. Then let's do all the 3/4 shots. Okay. Now let's run our rename script. All right, there we go. So now we have consistent names. All of the shots are first the side ones, then the back ones, then the front one, and then the 3/4. You can actually probably get rid of this rename.sh, to be honest. And let's actually bring this over here. Say chair example. And here we'll do boo. So let's copy that. Okay. The profile shot is the first. That there. Then the back shot. Then the front facing, and then the 3/4. All right, so profile shot is 0 to 5. Back shot is 8 to 11. Front facing is 12 to 17. What are you doing, bro, with NeRF? Making a NeRF from mid-journey v5 images. 12 to 17, and then 3/4 shot, 18 to 21. Okay. So now let's do Control-2, so we have a second window here. Let's get this transforms.json here. Okay, so we're basically going to want to copy this transforms.json. What is base cam? This is probably rotation, matrix, translation. We don't really know what these are going to be for our specific camera, unfortunately. So maybe we keep it the same and then we just kind of pray that it's fine. What else does the poster have? The poster has this like other extra crap here. It has like additional images. It has all map folder. Let's actually go to the Nerfstudio. Let's do Nerfstudio. They have their documentation. And we want getting started using custom data. So we have completely custom data. Process data. We're not actually going to use call map here because we need to basically and define these. Data conventions, this is what we want. Okay, here we go. So FLX, focal length X, focal length Y, principal point, image width, image height. These are going to be difficult. I think maybe the best thing to do here is to find a camera on the internet that has Nerfstudio example camera intrinsics. Camera models. No, that's not what we want. We want like providing your own data. Okay. Never mind. I think this is going to just lead down a rabbit hole we don't necessarily give a shit about. So let's go back to our VS Code here, and we're just going to basically use the ones that they have in the examples here. So actually, we can change this. We can make sure that the width and the height are the correct width and height. So where is my folder with cat images? Again, here, properties. These are image 1024 by 1024. Right here in transform, let's make sure this is 1024 by 1024. What else can we hand edit in here? Focal length, no. Image width, principal point X and principal point Y. I feel like these should just basically be the same, right? The X and Y focal points should be basically the same. So let's do 1150. Radial distortions. We can just say, we just comment these out. Let's comment out that. Let's comment out this. Let's see how many of these we can actually comment out and get away with. It doesn't seem like we necessarily need this AABB scale thing. Let's get rid of that. And, all right, 1 to 3 is the profile shot. Let's do this. Let's make sure. So we're going to copy the format of this one, frame 001. That's going to be the profile. That's not actually what we want. We want the other side of the chair. We want frame 89. So let's do 89. 00089. And we can actually delete everything up until that. If you perform a NeRF on Midjourney, shouldn't you also have camera information? Exactly. We do not. So we are going to try and spoof it. See if it works. Okay. And so that's the profile shot. The back shot is 44 to 47. So actually, let's open this, and let's also open this one. So delete all of this here. Can't have trailing commas in JSON file. All right, so back shot 44 to 47. Let's 00044. This one. I should do 45 just in case. This. That's going to be the back shot. We're going to have the front facing shot, which is 144 and 150. 150. 150, this one. Be the back shot, or the front facing shot. And then the 3/4 shot is going to be 173. So I'm copy pasting these camera transforms for the example into this fake camera transforms that I have created for the cat images, right? So what we're going to do here is we're going to copy paste this 5 times. Once, twice, 3 times, 4 times, 5 times. Zero, 1, 2, 3, 4, 5, 6, 7. It's actually 8 times. Five, 6, 7, 8. And we're going to do a replace here, and we're going to replace that with frame 0, 0, 0, 0, 0, 0, 1. Copy that. Okay. We're going to replace with 1, and we're going to replace with 2, and 3, 4, and 5, 6, and 7, and I think that's it. Yeah, okay, now we need the 4 back shots. Back shots, we have too many, so let's get rid of this. And we need 4 of these. 1, 2, 3, 4. And we're going to replace the names of those. We're going to do 8, 9, 10, and 11. Go all the way up. Replace this with 8. 9, 10, and 11. All right. Next thing, we got the front-facing shots. And we have 1, 2, 3, 4, 5, 6 of them. I'm going to copy this and paste it 6 times. 3, 4, 5, 6. Search for that. And we are going to replace with 12, 13, 14, 15, 16, all the way to 17. All right, and now we should be at the very end. We just have one more camera matrix to copy paste, and that is the 3/4 shot. 2, 3, 4, 4. And it's going to go from 18 to 21. 18, 19, 20, 21. Oh no, did this wrong. Actually, does it even matter? No, it doesn't matter. Okay, we're good. Let's just actually copy paste them just so we have 17, and then that's 21 to the end. After 20. Right here. And then make sure to remove that last comma. We save it. There we go. Now we have our fake camera positions. I don't know if we necessarily need this path. We'll see what happens if we don't have it. Let's save this in data Nerfstudio manual references. This nerf is still just training here. We at 38%. Render view. Viewport. Okay, we're going to pause this training because we no longer want to look at that. And we're going to load up the new data set that we have. So it's going to be Nerfstudio boo-boo. Right, this is probably going to error out. Yeah, there you go. Raw decode. Okay, something's wrong with our JSON file, which makes sense. We were manually importing or changing it. So let's open up the boo-boo. Here's our errors. Okay, you can't be doing that. Try it again. CX not specified in frame. Okay, so we do need CX. It's a good default value for CX. Principal point. Let's see. camera intrinsics principal point. Foot of the perpendicular from the interior perspective of the center of the lens to the plane of the photograph. So yeah, I think this needs to be basically symmetrical since our image is let's do CX. Let's do 528. Or, yeah, let's do 512 actually, just so it's like perfect in half. Let's do that. Let's run it. It's not C_X, it's just CX. All right. It's training, so let's go in here and verify that our fake camera poses are reasonable. Okay, so we have all of our images. And you can see here we have our fake camera poses for them. We have the front facing shot here. We have the 3/4 shot. And then we also have, ooh, the side shot here is actually wrong. See, this side shot here should be here. Yeah. So the side shot should be more like image 1. So let's open that up. And let's replace the transforms matrix with that. Which ones are the side shots? They're 1 to 7. So I think we can just do a replace here. So Control H. Seven of these when we put it in. Place all of them. Format. Control C out of that. Where does it put the outputs? What is inside this outputs folder? Okay, so I think we can just delete here in Nerfstudio. Did it put anything in here? Okay. It's actually CD workspace. We're inside the Docker container right now, and we're going to just remove this outputs folder just so we don't get any stale data in there. All right, and now we're going to rerun the Nerfacto training on the Baboo directory. And let's relaunch the visualizer. Okay. Render disconnected. Come on, what's going on? We did something. Let's actually close out of this Docker container. Okay, we don't have anything running. Let's rerun the Docker container. Now, let's do our NeRF train command. This one here, ns train nerfacto data nerfstudio boo boo. All right, let's open up the visualizer. All right, we're getting it. All right, this is still not ideal. The back and the front. Right, this should be the front of the cat. You have the side of the cat. There's a 3/4. That should be a little bit closer to the front. Then you have the full side shot. Then you have the back shot. The back shot should basically be across the origin from the front shot. Damn, this takes forever to train. 078, 080, 083. What if we change some things here? Also, is this even using our GPU? Watch every 0.5 seconds NVIDIA SMI. Yeah, this is using both of our GPUs. Look at that. Not a huge amount of memory, but certainly the actual... This one's actually probably not doing anything. It's probably only this one. Right, so you can look at the power consumption, and then you can look at the memory utilization. That'll tell you what's really getting used. Okay, so I think this is actually what the camera file is. So seems like there's a file, right? This not the poster, but this one here, basecam.json. I think this is basically the rendering video file. In the transform matrix, the first three columns are the x, y, and z, and the x, y, and z values to find the origin. The last row is compatible with homogeneous coordinates. So if we actually go here into the right, so it seems like this one here, that is starting to appear. I mean, it's just like this giant diffuse cloud. Okay, but this front-facing shot here is roughly, so normally red, green, blue tells you X, Y, Z, but not all the time. So maybe red, green, blue here is X, Y, and then Z, which means that this first shot here of the frontal should be at X1, and then Y and Z 0. So let's see if that's the case. If we look at our camera extrinsic matrices here, so front-facing shot, which is going to be frame 12, is X, Y, Z 1, 0, 0. 1, 0, 3. That's not quite it. Yeah, this is at X2, Y2, Z3. He's really at Z3? Yeah. So I think one of the first things we can do is we can make the Z height all the same. So you see this part here? We control F for that. How many of those are there? There's just one. What if we change it to 2.9? These other ones have. 2.9 D plus. Change it to regex here. Or star D, something like that. Star D, or D star. And dash new. You know who is going to know how to do regex? Good old friend, chat OpenAI. Can you write regex for me that will place the long float 2.97 in this JSON? I want it to only check for the first two decimal places. Yeah, this is what I wanted. I wasn't too far off. It's 2.9 -d star. Okay, this is matching 6.9, 2.9, 2.9, 2.9. Actually, it's matching 9, 1.9. You know what would be a better way to do this is we just replace this. No, I think we have to make a Python script. Let's see how our Nerfstudio is doing. This is very confused. It's trying to find some kind of abstraction to like fit it in, but it's just like these shots are very, very confusing. Can you give me the transformation matrix for a forward-facing camera shot? I want it to be zeroed out on the, I want the Y and Z axes to be 0. Camera transformation matrix for a forward-facing camera shot where the X and Y, H and Z axis are both 0. You're essentially looking for a matrix that only captures movement along X. Okay, true. 4x4 would be the identity. Okay, let's see, let's make sure. No, if I'm looking at this, right, you see how this is close to 0, close to 0, close to 1. So it's more 0, 1, 0. Does this matrix make sense? This is going to be 0, 1, 0. Or 0, negative 1, 0, sorry. And then the X is going to be 1. Then 1, 0, 0. And the X is going to be, or the Y is going to be 0. And 0, 0, 1, and then the Z is going to be 0 as well. And then the last one is always 0, 0, 0, 1. Okay. Here's the interpretation of the matrix. "90-degree counterclockwise rotation around the Z-axis." that consistent with what we want? X is right, Y is up, Z is pointing back away from the camera. Negative Z is the look direction. Okay, so actually we're wrong. So one thing we could do is actually we could probably open Blender and get camera matrices from there. Our computer might actually explode at this point. Okay, so here you see this camera. This is a camera in Blender. So look through that camera and let's replace this cube with a mesh monkey. See here, this is the rotation matrix up here. So this is what we actually want to change. We want 0, 0, guess Z0, but we want X to be 1. We need X to be a little bit more than 1. Let's make X 3. Rotation, we want 0, 0, 0. And actually we want a 90 here. A 90, not negative 90. And we also want a rotation around X of 90, negative 90. I think it's around Z. Oh. What is going on? Rotate X like that. So you see it's actually a little bit more complicated. It's 90, 180, 90. And negative 90. Shift duplicate. Actually, why don't we add a constraint here? Constraint properties. Tracking, motion tracking, we want follow track. Right, and no, that's not what we want. Like a track 2, clamp 2, limit location, limit scale, transform cache. We want track 2. And the target we want is the monkey. All right, so now if we actually move this, Oh, we already created an extra one. There we go. This is the one that has the constraint. If we try to move it, no, that's not what we want. There we go. Okay, so we have front facing, we have the quarter facing, side profile, the back. So before we do that, let's go into the actual camera itself and make the kind of intrinsics and extrinsics kind of similar-ish to what the Midjourney created. So let's actually scale this down so it's a little bit smaller. Okay. It's camera 2. Rid of that. How's our NeRF doing? Yeah, these just look like crap. There's nothing even there. Okay. Render properties, layer properties, object, camera, viewport display, custom properties, type, perspective, okay, and now, before we go ahead and start messing with this too much, I think there's an output. Can you write the Blender Python command for me that will output the transformation matrix of a camera object? Okay. So bpy.data.objects, bpy.data.objects, camera.001 dot matrix world, matrix.local. All right, I mean, I'm getting a matrix there, but that's really what they want here. Okay. So actually, one thing I'm going to do here is I am going to make a Python file to do this. So create transforms. Create cam pose is. All right, so we're of course going to need OS. We're also going to need to have a list of all of the different shots. So we're going to have the front facing, we're going to have the back facing, we're going to have the profile left, I guess, profile right, I guess, and then the 3/4 as well. Three-quarter front facing. And here's where we're going to put the paths to our files. We're going to have a root path, or actually image to set path. We're going to need our images again. Where are they? Stan images. Here. Okay. So we'll say portrait left is when the cat is facing left, and portrait right is when it's facing right. So portrait right here is going to be frame 0, 0, 0, 0, 0, 0, 0, 0. And now we're just going to do like this, and we're going to wait for Copilot to do it for us. All right, we got 9, 8, 9, 10, and 11. 8, 9, 10, and 11. Three-quarter front facing, we have 18 through 21. And then front facing, we have, that's pretty crazy. I don't know if you guys just noticed that, but like GitHub Copilot was able to realize that all the frames that we have here, the ones that are missing are starting from 12. That is crazy. See in here, it doesn't want to autocomplete because it already knows that there's an 18 here. It's very good. Okay. So we need a dataset root path. Then we need a dataset output path. We're going to call it images 0. And call it, and we don't need to have a name for that. Okay. So now we also need to define the matrices for each of these different shots. So let's go ahead and say string. Okay. Let's ask ChatGPT to actually format that nicely for us. Can you format this matrix for us so we can assign a Python variable to it? Okay. So this is going to be our we're going to have matrices for each of these. So we're going to have a front-facing matrix. TQ front-facing matrix. Let's see if Copilot can actually do this. No, it just outputted what we already had. A back-facing matrix. I don't think that's quite right either, but we're going to check. And we're going to have a profile left. Right, let's actually think about this in world space coordinates too. So it's another thing to realize here. Let's go into our Blender. Go back to our modeling tab. Let's copy, paste. Don't want Suzanne 1 and camera 2. This one. Shift 8. That. Shift 8. Have like a top-down view, so at least it's constrained. This. 3/4 view. Then the right profile view. And then the back shot. Okay, so those are basically the shots we have for our cat, right? Yeah. I think those look pretty good to me. Maybe this one is a little bit lower. This is G, Z, put down a little bit. But these other ones are fine. Let's actually see what this looks like. Yeah, that's what we want. So camera 002 is going to be the front facing. Can you do the same with this matrix? Round the round any floats to the nearest digit. Let's turn off our Roomba. This is not rounded. Those aren't rounded. Can you round them to the nearest ones place? Like on the back camera angle, that's going to be camera 5, so we can actually do here and do that. Here we have the transformation matrix for the front shot. Go ahead and put that in our script. Okay. Let's copy the back shot here. Stop generating. Can you do the same with this matrix? And then camera 1 here. Oh, right there. It is what it is. Let's do camera 2. It's camera 2. Camera 2. Let's do camera 3 actually. Okay, and this should be the back. This is the 3/4. So we have our front facing, we have our 3/4, we have our back facing, and we need our profile left and our profile right. So let's do this. And let's do that. So let's look at camera 1. Camera 1 is the left facing portrait. So left facing portrait should be at x equals 3. Left facing should be at x equals 3, perfect. And then the right facing should be this camera, which is camera 4. That is what we have here. Okay, let's go back to our GPT. Same, but with and here it should have a -3 for the x, which it does. All right, perfect. And just to confirm, camera 4, which is the one that has a -3 for the x, we look at it, it should be portrait right, which is indeed what we have here. All right, so We have the names of the camera matrices for each of these canonical positions, photography positions. We have, let's call this 3/4 right. 3/4 right. And we'll move back facing right next to facing. Okay. And we eventually need to create this transforms.json. And this file's pretty simple. The only thing it needs to have is this stuff here. So why don't we go ahead and actually copy that from these here. We'll go into our create compose. Once we have all these things defined here, let's do if name on. You should know the ending to this, Copilot. Name equals main. It's not exactly what I want. Okay, let's do camera intrinsics. Here's where you're going to have this. I guess we don't need the brackets. Here we can replace this with that. We can also link to this page here. And we'll do that. Let's get rid of these. Oh. And let's get rid of that. Have FLX, FLY, CX, CY, WH. FLX, FLY, CX, CY, WH. Okay, to make sure those were correct. All right. There we go. Now we have our camera intrinsics. We're going to create JSON file in dataset root. It's not called camera intrinsics, it's called transforms. And let's actually pull this out. Let's have a JSON file path like that. And here's where we'll actually do this. JSON file path as W. Maybe we do this in the end. Ideally, I'd like to be able to write it as we do it, just so if it breaks, it doesn't crash everything, right? You'd be storing it. So let's add metadata to JSON file. Write camera intrinsics. It's not what I want. This is a dict. List of dicts. Okay. Let's do frame default dict. Okay, so it seems to be basically a relative path. So first thing we're going to do is start up dictionary with data. Okay, we're going to call it data equals copy, deep copy. Let's go all the way up here. Import copy. Jesus Christ. All right. Then we're going to initialize the frames as empty. Then we're going to do this part here that GPT wrote for us. For file and files, if file and front facing, continue, output path, the output path. No, what we're going to do is we're going to say frame is going to be a dictionary. This is where we're going to paste in our default dictionary. This is just going to be the file. And this here is going to be the matrix. Data append frames. Then finally, we write it to file. Okay. So instead of manually editing the JSON like we did a couple times, we're now going to be creating the JSON with a Python script. We have some matrices that we got from Blender that represent the different camera poses in the images that we generated from Midjourney. So obviously, the exact camera pose for these Midjourney images is not known. So these are approximations from Blender, right? We have some fake cameras that we set up that are like a little bit similar-ish to the camera poses from the Midjourney, and we're basically going to try to see if we can create a NeRF from that, or whether the resulting NeRF will just be a bunch of garble. So first thing we need to do is we need to recreate the transforms.json file. So let's see. We also need to import the JSON library here. We don't actually need this output path. Or actually, yeah, we do. All this transforms gen.json. Comment out this, and we'll say that. Let's go ahead and run this. I want to do this on a new tab. Not the one that has Blender open. Guess maybe this one. No, let's get rid of that one. We'll leave Blender over here. Yeah, this is what we want. Okay, so we're inside our better repo. We're inside this thing, and we're going to do actually conda activate. We shouldn't need the Nerfstudio conda environment because this Python script does not have any dependencies, but let's just go ahead and do that. Run that. Okay, kind of instantly ran. Let's see if there's anything different in our data. Actually, we might as well just open it here. So there should be a new file in here called transforms.gen. Let's format that nicely just so we can compare it. All right, so right away we notice that the file path is incorrect. It just says file. It should be the actual file name. But other than that, it does kind of seem correct. Okay. So here in camera, file path should not be file. The file path should be file. Try it again. Frame 0006.png. I think that's good. That's what we want. Okay. See, FLX, CX, CY, are all those there? Yeah, that all looks good to me. Okay. So let's delete. Or not delete, but let's kill our currently running job here, which is at 69%, but if we go to the actual Nerfstudio, quite easy to tell that this thing has no idea what it's doing. It's just kind of creating this giant mist cloud of nerfs. So let's pause training. We'll Control C out of that. Close out of Nerfstudio. Let's remove the outputs folder. Why don't we also just Control C out of the Docker container, rerun the Docker container just to make sure there's no cached stuff here. And let's go ahead and do NSTrain. I think it's Nerfacto. And we want it to use the what? Oh no, I think it's like we need like the data dir part. All right, wait a second. It's NSTrain -- data. NSTrain Nerfacto train Nerfacto -- data. And then this is where we do Nerfstudio. Boom, boom. And let's go into that folder. Let's move data Nerfstudio boo transforms .json. Let's move it into data Nerfstudio transforms. We'll call it old, or actually let's call it manual. And let's move the new one, which is right now called _gen. And let's just move it so that it's called transforms.json. Should go here. We'll close out all of these things. Go back to here, and we'll run this NSTrain. Now we will have to relaunch no such file or directory frame 000000015. Let's actually exit out of that. Let's go into this terminal. Open up a new tab here. We're going to go into the data Nerfstudio boo clear nautilus here. We have transforms. This is empty, which is fine. I think we need either of these. Let's kill both of those. And it's saying I can't find frame 15. Ah, okay. I know what's going on. These here, need to put them in the actually no, let's keep them in here. Let's just change our script that it correctly create cam poses. So the file path should be images /images / file, like that, so that it finds it in the correct directory, and let's change the name of the output path to transforms.json. All right, let's rerun this file. Now let's try to rerun this Docker image. Okay, we need to get rid of that dot. This needs to be like that. Rerun it. All right, it's going. We're live. So let's go. All right, let's see how these are looking. Okay, this is looking a lot better. You see this? We have the front and the back shots are directly across from each other. Right? You have the 3/4 shot. That's a little bit right there, which is what we want. And then we have the correct profile shot here as well. So we do fast. Doesn't feel fast. All right, let's see if there's options we can give to make this faster. Does this work? Can we do do that? CUDA visible devices. 0, 1. Let's also change these matrices. I think they're a little bit too far away. Right? I feel like these 3s should be 1s. Should only be like 1 meter away. And make this 0.75. 1. Make this 1. Generate that again. And rerun this. I'll make the poses closer together and it should be better. Okay, you see now they're a little bit closer. Using both my GPUs now? Feels like it. %38 of time spent on viewer. So if I don't have the viewer on, it goes faster. Okay, so what if I exit out of the viewer? Let's go into here. Let's do NSTrain help. Okay. Slow, slow, slow. Is there one that's fast? Ooh, Nerfacta with depth supervision. That might be something we could look into. You know, if we can probably get depth images from our cat images, and then we could use it. Okay. Did I even mess with these? I should also copy this to the README, just so we have access to it. And we want this. We want machine.num use 2. Change the learning rate. You don't see much value at the moment for running the fast methods like Nerfacta with more than one GPU. It doesn't really sound like there's faster versions that you can run. It sounds like the different implementations are faster than other implementations of like these different types of nerfs, but within each specific nerf, like you're better off just running the default. So let's go ahead and try that. We'll try this 2 GPU version of the Nerfacto. And we're not going to open up the visualizer because it was wasting 40% of the time on the visualizer, so hopefully it should go faster. Jesus Christ. Estimated ETA 3 hours and 39 minutes. What am I supposed to do the rest of the time? And no one's going to sit here for 3 hours and 39 minutes. Huh. Okay. I think I'll probably have to let this train, and then I might come back tonight to this, and then I'll stream again. But I guess I can run over what we did if you just joined and you're curious what we've been hacking on. So basically what we did is we generated a bunch of different images of Babu, that is Boo, which is the cat that lives in this house, and that is on all the branding for this YouTube channel. But we generated front-facing camera shots, like kind of profile camera shots, backwards-facing camera shots, and then we went ahead and we got camera extrinsics for each of those different types of poses based on this little Blender file here. We should actually save this Blender file as well. File, save, and let's put it into our data folder. Data, Studio, Babu, camera poses. Save. All right, we're gonna close out of that. So we generated these with Midjourney. We got estimates for the camera poses using Blender. We used ChatGPT to format those camera poses into a nice, clean Python dictionary. Then we made a little script in Python to basically given the names of those specific images and then the matrices for each of those from Blender. It basically writes it into this transform.json file. And that transform.json is used along with the images by Nerfstudio, which is a Nerf creation library. And Nerfstudio is running in a Docker image. So it does its own little thing. You can see here roughly 1 hour remaining. But yeah. Did you see Copilot X? Yeah, I heard about it. I kind of really want to try it, so maybe I go do that instead of waiting here for this Nerf to train as it slowly kills my computer. Okay. Food station, is Copilot X, like, could I set that up right now, or do I need to like do a bunch of internet stuff? Right? Is it like a waitlist situation, or is it just I just need to update VS Code? No waitlist. Uh-oh. Sounds like I need to use it. Copilot X. Oh yeah, there is a waitlist. Okay, I'll have to Copilot X waitlist. Oh my god, my computer's dying. This GPU Nerf. Introducing GitHub Copilot X. Yeah, it's basically the chat interface. which is good because the tab autocomplete is like useful for Copilot, but it's also great if I was able to use kind of the chat interface. Sign up for the technical preview. Join the waitlist. Shit. I need to pause this nerf or my computer's gonna explode. Okay. This is just Copilot for docs. I want the waitlist. Wait, there's waitlists for different products? Pretty sure I already have this. Enroll your repository. Stage waitlist. Where do you plan to use GitHub Copilot chat? Visual Studio Code, join the waitlist. No, I didn't get access to GPT-4 API access, unfortunately. I think they figured out that I'm going to use it to build products that compete with OpenAI, so probably going to ban me. Okay, so I guess I'm on the wait list now. Sick. Thanks, Food Station, for the heads up. And we now go back to our state of sitting around waiting to get in through all these wait lists. All right. I'm going to run this again. I'll come back later. If isn't the collab more powerful than your local GPU? Probably not. Maybe this GPU is not great, but I have better GPUs that I could run this on. It's just going to be a pain because my better GPU is on a different computer, so I'd have to set up the CUDA 11.8 again. I spent like way too much time this morning setting up CUDA. Any of that. Any of that. Close some of this crap so that the computer runs a little faster. Don't need that, don't need that. There's like a Blender add-on. That's very useful. Learn more about Nerfacto. Nerfacto model acts as our default real data capture of static scenes. Combination of many published methods that we have found. You have your ray bundle. Okay, that goes into a piecewise sampler. So they're sampling along each ray, and they probably have a certain amount of pieces that the ray is split into before they sample. That gives a XYZ and a dir, which is the view direction. Two density fields here. Okay, so I guess maybe you can use clever sampling to reduce the amount of points in low density parts of your field, be my guess. It's not uncommon to have errors in the predicted camera poses. Yeah, our errors are going to be huge because we have mid-journey camera images. Let me give you $1 million of ideas, okay? There is no certain AI for coding image to code. Think you have a photo design for Midjourney, but the design cannot be turned into front-end code. You're talking like an inverse map? Isn't that what, isn't that literally what the YouTube Greg Brockman demo? Yeah, this.
To the GPT-4
I think he does exactly what you're talking about here. He like gives it honestly, a picture of the front end that he wants. Right here, maybe here. Oh, I see what you're saying. Not like a design from Midjourney or professional ones. Yeah, I also don't know how far 2D goes, man. I think that's also part of it. You know, when you think about it, right now, all of our interfaces are based around point and click. So like even YouTube, like the whole YouTube is based around the fact that I have like this little mouse and I'm sitting here and I'm clicking on things. But once you have like speech to text and then you have LLMs, all the user experiences and user interfaces would become voice, right? So what does the voice interface look like for YouTube if you don't have to click on things and it's all voice based, right? You can just sit here and talk to YouTube and it creates stuff for you. So I could see websites in general, right? Even like this documentation website. How much more different would this look if there was a little bot that you interacted with that would answer all your questions related to Nerfstudio, rather than you sitting here and clicking on specific things and like looking here and scrolling at this section and copying, right? I think front end and websites just in general they're going to be very different even in just like 4 years or 3 years than they are now. I don't know if I really helped, but it's a good idea, man. If you're interested, you should try it. That's what this AGI release party is all about, is trying all kinds of cool ideas. right. I'm going to actually try and train this. All right, I'm coming back in 1 hour, potentially. If I don't come back, then you guys know that the output was terrible and we'll figure it out. But if not, thanks for watching part 2 of the stream. Hope you guys have a good time and see you guys potentially later tonight.